Okay, hi, I'm Daniele Guariso, and I'm a PhD student in economics at the University of Sussex and a visiting student at the Alan Turing Institute. So this is submission number 62, Budgeting for SDGs, a data-driven approach, and it is joint work with Omar Guerrero and Gonzalo Castañeda. Okay, here's the outline of the presentation. In the introduction, I will talk a little bit about the Sustainable Development Goals and the 2030 Agenda. Then I will try to propose some reasons why governments should incorporate the SDGs into the budget process. And I will explain the aim of this study. Then we will move to the data description section. I will talk about the development indicators data, the government expenditure data, and how we combine them to build the final data set. Then we will move to the core of our research with the analysis and the results. I will discuss them in relation with our specific case study, and then I will briefly conclude. Okay, so let's get started. In 2015, the United Nations adopted the 17 Sustainable Development Goals. These are very broad and ambitious global challenges like no poverty, gender equality, quality education, but they are shared by all UN member states with the aim of achieving them by 2030. These 17 goals are further divided into 169 targets that are more specific and measured through relevant indicators. Now, there is a list of official indicators, but then basically each country has developed its own additional statistics. Now, when it comes to achieving the SDGs, it is clear that governments and their policies play a pivotal role, right? The way in which they allocate resources through public spending is crucial to the progress towards the SDGs. However, it's not easy to understand which budget programs a government should prioritize, because we might have spillover effects. For instance, we might invest in the quality of roads, and that might have a subsequent impact on the commuting time for school children, and that in turn might affect their educational outcomes. So it's not easy. However, for the moment, let's take a step back and let's ask ourselves, why should governments incorporate the SDGs into the budget process? Well, first of all, because it helps the alignment of the budget with the medium-term objectives of the government. And this is actually one of the 10 principles of good budgetary governance proposed by the OECD. Then, because by incorporating the SDGs into the budget planning, governments can have a coherent way to allocate resources within a sustainable framework that tries to encompass the complexity and interplay of development processes. And this sustainable framework is shared by the international community. As I mentioned before, the SDGs are common to all UN members. So we will have national development plans in alignment with international commitments and a common framework to compare them. In addition, from a principal agent perspective, linking the budget to the SDGs increases government's accountability. Since the SDGs are measured through indicators, we can use them to track and quantitatively assess the performance of government's policies within a sustainable framework. So it seems that there might be gains from this exercise, that is linking the SDGs to the budget planning. However, it's a tricky exercise. Why? Well, because as we said before, basically governments do not know which budget programs are the most relevant to the progress towards the SDGs. And if we want to create a mapping between the SDGs and public spending, first we need to understand this. So the purpose of our study is to provide a flexible, data-driven framework to analyze the relationship between public investment, public spending, and improvements in the SDGs indicators. And it is divided into two steps. In the first one, we use the information that we have on the historical trends of the indicators and public expenditure to build a model that we can use to predict an improvement in the SDGs indicators. Then in the second step, we use that model to identify those expenditure categories that are the most relevant to our predictive model. Now, the idea is to provide a framework that can complement contextual knowledge and help policymakers to effectively integrate the SDGs into budget planning. Now, our study focuses on a specific country, Mexico. Why? Well, because the Mexican Treasury has made available an impressive amount of highly disaggregated fiscal data. And I invite you to have a look at it by following this link here. Okay, and since we are talking about data now, let's have a quick overview of what we are going to use in our analysis. So we collected the information on 456 indicators that are measured on a yearly basis, and that span the period between 2008 and 2019. They come from different sources: the Mexican National Statistics Institute, the World Bank, the Sustainable Development Solutions Network. And as you can see from the figure here, their coverage varies quite a lot across the different SDGs, ranging from 6 indicators for SDG 10, that is reduced inequality, SDG 13, climate action, and SDG 15, life on land, to 83 indicators for SDG 4, quality education. Now, as you can imagine, these indicators are really diverse in their nature and unit of measurement. I put some examples here, like the prison population per 100,000 people and the forest area in square kilometers. Then we have the government expenditure data. As I mentioned before, this is highly disaggregated data on government spending that come from the Mexican Treasury and that cover the same time period as the development indicators data, so from 2008 to 2019. We have information on 803 budget programs, or in Spanish, programas presupuestarios, that are characterized by the type of services or products they provide, their modalidad. They are also grouped in 41 ramos that are macro categories of expenditure, like work and social welfare, public education, energy, and so on. In this figure, we have the proportion of budget allocated on the y-axis. Is the proportion of budget allocated to programs grouped by ramos. And we only report some of the ramos. But you can already see that there are systematic differences in the allocation of resources across these different macro categories of expenditure. Now, to build the final data set, we combine each development indicator to all possible budget programs, but separately, for every ERT. So basically, we take the first development indicator in 2008, and let's just move this here, and we link it to the first budget program in 2008, and that is one observation. Then we link it to the second budget program in 2008, and that is a different observation. And we continue for all budget programs in 2008. Then we move to 2009, and we do the same. And we continue until 2019. Then we move to the second development indicator, and we apply the same strategy. And we do the same for all development indicators in our dataset. So as you can see, we are allowing for all possible combination of development indicators and budget programs. Now, after additional cleaning, we obtain a final dataset with 1,118,073 unique observations that we are going to exploit in the following analysis. Now, as I mentioned before, the first step of the analysis is basically a classification task. We want to predict an improvement in the SDGs indicators given their historical trends and changes in public expenditure. So formally, the specification of the model is this one. So the output of the model is a dummy variable, so a binary variable, that takes the value of 1 if indicator I improves in year t+1. Then as inputs, we include the relative change of the indicator in year t and one lag of it. We also include the relative change in the expenditure level of the associated budget program J in year t and 3 lags of it. And we also include a vector containing dummy variables for all the ramos. And we are going to use these variables here in the next step to identify those macro categories of expenditure that are the most relevant for, to our predictive model. Okay, so now a little bit of technical details. Here we compare 3 different classifiers, a standard logistic regression to more advanced machine learning methods. We compare it to a random forest, for which we optimize the number of random inputs that are considered at each split and the number of trees. We also employ a multi-layer perceptron that is basically a deep neural network with 3 hidden layers in this case. And in each layer, we use a different activation function. Here we optimize the number of neurons in each layer, the number of epochs, and the learning rate of the optimizer. These hyperparameters, as those mentioned for the random forest, are chosen within a nested cross-validation framework. Okay, here are the results of the model comparison. As you can see, the random forest outperforms the other 2 classifiers across all the metrics that are precision, recall, the F1 score, that is basically the harmonic mean between precision and recall, accuracy, and the area under the curve. Now, if we look at the random forest and we compare it with the more traditional approach, that is the logistic regression, we observe an increase of 46% in the accuracy and 99% in the area under the curve. So, not bad. Now, once we have established the superior predictive performance of the random forest, we can actually use the properties of this 3-based method to study the relative importance of the ramos, those macro categories of expenditure that we included among the inputs of our predictive model. We rank them by their mean decrease in purity. Now, since the splitting criterion in our random forest is the Gini index, the mean decrease in purity in our context is also called the Gini importance. The table here reports the normalized values of Gini importance for the 10 most relevant ramos. Here we normalize the values considering only the dummy variables for the ramos, because basically we are only interested in the relative importance between these inputs. So these are basically the 10 ramos that appear to be the most relevant to clearly predict an improvement in the SDGs indicators. The first one is finance and public credit. Then we have environment and natural resources, public education, communication and transports, and so on. Next, we perform the same type of analysis but at the SDG level. So basically, we only consider those indicators that belong to a specific SDG. And instead of using dummy variables for the individual ramos as inputs among the inputs of our predictive model, we use a full set of binary variables for all the budget programs. So basically, right now, we are interested in those budget programs that are the most relevant to a specific SDG. And here we report, Here we report the results for SDG 8, that is decent work and economic growth, and SDG 3, good health and well-being. So when we look at the most relevant budget programs to the SDG 8, we see management and regulation of rural property, detection and prevention of illicit financial activities, and minimum wage assessment. It is interesting that when we move to the other SDG, the same 3 budget programs show up. And this might suggest that these programs have a broader impact than one would expect, with potential spillovers across different SDGs. Okay, but now let's move back to our first set of results about those ramos that we identified as the most relevant across all the SDGs. And let's have a look at the budget allocated to those ramos over time. So in these figures, on the y-axis, we have the relative change in budget allocation for those ramos that we identify as the most relevant ones. And it seems that, especially in the last years, we consider, there has been a systematic disinvestment in these macro categories of expenditure. Here we simply regress the relative change in the budget allocated to a program to the full, on the full set of dummy variables for the individual ramos. Here we report only the estimates for the ramos that we identified as the most important ones. The negative and significant coefficient on most of the variables further support the insights that we got from the previous figures. So it seems that on average, over the last years, those ramos, those expenditure categories that we identified as the most relevant to the improvement in the SDGs indicators, so to the progress towards the SDGs, have been systematically neglected. Okay, so to conclude, we have tried to provide a flexible data-driven framework to identify those expenditure categories that are the most relevant to the progress towards the SDGs. Such a framework could help treasuries around the world in making the best use of their resources and help thinking about potential spillover effects of budget programs across different SDGs. Finally, this whole exercise was made possible thanks to the availability of open and highly disaggregated fiscal data. So with this work, we want also to emphasize the importance for governments around the world to make fiscal data open, accessible, and transparent for everyone. And that's it. Thanks for listening.